Hello everyone, my name is Pankaj Gupta and I'm a cloud architect engineer with overall of 10 years of experience. So in today's class, I'm going to teach you how to create a three-tier architecture, which is very important class because nowadays how company follows the standard to deploy their applications. So if I talk about any applications which is used by any company, which is the product of any company, whether it be banking applications or entertainment platform, any platform, we have a web service or application. It is mostly deployed nowadays in a three-tier architecture. There's a reason behind to deploy the application or web services in a three-tier architecture, because there are lots of benefits that I will be covering in couple of next minutes. So let me talk why this class is very important for all the people who are looking for a new job or job change in cloud architect domain or DevOps domain, even those people who are freshers actually, who are looking to learn lots of stuff about DevOps. So I will be starting directly about three-tier architecture. So nowadays companies, for example, let's take example of Facebook or phone pay applications. In the backend, the application or product is deployed in some servers. Mostly they are orchestrated in a Docker platform, or the microservices are running behind those applications which are responding to the front end request. So for example, if I talk about PhonePe, so PhonePe is having some code which is deployed in the backend server. There must be a database which is attached to the application, and there's a front end which is used by user. So when I am or somebody is doing a initiating a transaction from using PhonePe or doing some any activity, there's a front end available in terms of apps. So that app is just a front end. There's a back end which is actually running behind that and receiving all the requests coming from the front end. That request is handled by all the microservices which are responsible for doing its functionality. For example, if I'm recharging something, there must be a code responsible for recharging process. So for each kind of task that I'm doing from front end, this is being handled from the backend applications. There's some code that is running in the server, and furthermore, there's a database attached to the application. So this is called like this is a generic scenario nowadays in any company to deploy any application, whether it be a mobile based application or GUI based application or any platform they made us available. So we will talk about this front end application and back end deployment, how this is deployed in a three-tier architecture. So but what is three-tier architecture? Let me demonstrate you and show you what how we can approach to create the three-tier architecture. So here uh, let me show you. So I just talked about, like, if we talk about phone pay, so a user is there which is using the front end. There's a front end of application. It could be of any application. It's a banking application, it's a Facebook or any platform where user is interacting directly and just putting some data, getting some data. And this front end is for further attached to the application, which is actually the code which is running for that specific application. And then the application is further attached to database. So let's take another example. If this is a Facebook user and he's creating or posting some data in Facebook user, the interface that is available in the facebook.com. This is a front end available for the user. So the front end is further communicating with this data he's getting, and that we are putting from browser or application, and then it is processing. The data is processed by the application. So basically application is something that is working on that data to do a specific activity. For example, if he's doing or recording something in the Facebook live recording, there's some backend code which is responsible for recording or doing a specific task. So each of the code there, each of the feature available there is having some backend code running. It can be running in a microservices architecture or in single specific code or in monolithic architecture, you can say. And there's a database attached to it because the application would need to put all the queries and receive the queries and put all the user data somewhere in the database. So there's a database. So it's just a simple raw architecture which is mostly company following to deploy their applications, and that is how in industries is running. So the front end, you can say it can be designed of CSS, JavaScript, or maybe HTML. An application could be of design like Java. It could be design of Java, microservices, or any platform and any code that is depending on the company or requirement of the company, like how they have designed their infrastructure. And there's a database. It could be MySQL, SQL, PostgreSQL, or maybe RDS. So to deploy any application, we would be needing a platform to where we can create complete this architecture. So this is somehow a three tier we are talking about. We can say this is the first layer, this is the second layer, and this is the third layer. This is we are calling three tier. The first tier is interacting to the user, which is public, because this is interacting to user. So this should be available to the public. The backend is somewhere code is running. So this is private. This is public. And again, the database should be private. The reason for keeping these in different layer is like this is the benefit of a three-tier architecture. We can keep each layer isolated. There's a security can easily be implemented. There's a compliance that we can take care of. And there's a like the portability of code, and isolation can make it very easy to define the barriers and add the security in each layers. So this is benefit of the three tier. We can read more about three tier architecture. There's lots of documentation over the internet. So this is a very generic architecture that I just talked about. So based on this, I will be further creating a complete architecture in a specific environment. So to create this architecture, we would be needing a platform. I would be choosing, in my example, AWS. We can optionally choose GCP, Azure. So we have the option to choose any platform. We can even deploy the architecture in local environment, local VMs as well. But I'm going to deploy this or show you the demonstration in AWS platform. So this is just, I just talk like this is a very simple architecture. We can implement a standard architecture in the cloud, how it will be looking like. So if I extend this further, so how I can think of designing the same architecture is, we will be creating in AWS one user. This is AWS, you can say. In AWS, there's one user, IAM user, which will be used by developer, you can say. Right now, I'm going to create here from their terminal to create the complete architecture, terminal, or you can say console. So we will be creating this. So I would first of all will needing a IAM user, which can be of any name, that will be having access key And this AWS account, like if you know a little bit about AWS account, then we have like logics of regions, like availability zone, that I'm not going to discuss in this tutorial because it's going to extend unnecessarily. So there's any questions or any concerns, you can reach me in the comment section, and I will be explaining in further more sections or videos that I can create. So this is AWS account, and there's a region. Each region is having a specific resources, and we have choice to uh, select the regions based on our availability. Like if I'm in India, so I will be choosing nearest region, or we can choose of any region, but depend like what are the costs. So based on the cost, we choose the region. So in one region, I will be creating like this kind of architecture. So this, I'm going to extend the same flow that I just show you. There's a front end, there's an application, there's a database for any kind of application deployment. So this is AWS cloud account. I will be first creating one public subnet here. This is going to be public subnet. We will be explaining more about each of the section, why we are going to do this, why this is the approach. So this is something we are talking about. What is three-tier architecture? There are lots of video over the internet that you can refer for better clarity of the three-tier architecture, and what are the benefits just that I just talked few minutes back. Like we can have the isolation of in each layer. There's a compatibility with that we can use. There is a compliance that can be implemented. There's a security that can be implemented. So these are the benefits of using the three-tier architecture. As we can see, we can isolate each of the layers separately. So now front end is something that I just said. This is the developer who is going to create the architecture. There's some user as well, or you can say client, who is going to use this now. So suppose if I have deployed any application like Facebook, there's a front end I will be making available here. So the front end will be coming from public subnet. So I will be creating a VPC first in AWS, and inside one VPC, you can say one availability zone. For now, I'm explaining this to create one availability zone based um, deployment, but there's an option always to deploy the same in multi availability zone. So for now, I will be explaining in this demonstration to show you like we can choose in one availability zone or multi as well. So this is AZ and VPC. Inside one VPC, I will be creating public subnet, and this is a private subnet, and again this is a private subnet. I'm going to explain why this is the layering. So the front end is used by user, and the front end code is some GUI code, or that can be a curl request as well, or SSH connection as well. So this is something always interacting with user. That's why it's called front end, and front ends would be kept in the public subnets, because the public subnet is something which is exposed to internet gateway. So there's an internet gateway where the public subnet is uh, routing. I mean, we can connect to internet using the public subnet. So we can any user which is having the access of server can easily, or the front end API GUI of application can easily access the application from the front end. So that's why kept in the front public subnet. Now here is the private subnet. Private subnet is something, this is the actually mostly asked question. Like this is what I'm explaining right now, the three-tier architecture. This is very important concept, and most of the interviewer ask this question. There are a lot of questions that can be arise from this concept, like what are internet gateway, why is public subnet required, what is the difference between public subnet and private subnet, what is front end, what is why application is kept in the private subnet, why database is required in the private subnet, and what is the net gateway, why we will be needing net gateway, like that. There's lots of concept. So I will be like requesting please keep your focus here only. Like this is very important concept I'm going to show you for any kind of deployment, because if you're going to switch your job in DevOps or cloud architect, or even if you're freshers, this is very important concept for any kind of applications. Once you are able to create this architecture, then you are able to deploy any application. So company to company application varies, but this architecture remains the same. So that's why if you learn this concept, it is going to the generic concept to learn, and you can create this platform in any company to deploy any applications. So let's move back, come on this the same topic. So the public subnet is kept connected to the internet gateway. So and it is accessible, or you can say is exposed to internet gateway. And now private subnet is private. Why we call private subnet? Because it is secure, and it is not exposed to public internet, and it is somewhere like no user can directly log into the private subnet. It is isolated from the public subnet, and we can set up security group rules to connect to the private subnet for a specific user. NACLs, you can say NACL and security group. So that this can be isolated and kept private. Nobody can log in directly here. The reason behind this is why we need private subnet is because company never wants their code to be explored by another user. Somebody if may come here and log in here and steal their code, and the code is something which is very important part of the company. It's kind of assets of the company. So if suppose PhonePe is going to give you your code, then you can create your own application as well. It can be any front end look, but the base backend code is something very important. This is another reason. Like anybody can come here and anybody can steal the data from this front application running a backend code. And maybe if it is banking application, it is going to be very dangerous for the companies or banking sectors or the users as well to have the security destroyed. So that's why we are keeping this in the private subnet. So the application is which is the backend applications or the core code, you can say. I say it core code application, actually code this is kept in the private subnet. Furthermore, when this application is running, it will need to interact with the database. The reason database is something which is having all the data. Application is something runtime code. It cannot have all the data from coming from the front end of the user. If it is Facebook application, cannot have all the photos, videos, posts, etc, all the banking informations. If it is a banking application, so it will need a database for the user data and for the application API kind of logic. So this will be needing a database. So that database is also kept in the private because nobody is able to reach to database, or no front end or public user can directly log into the database or even the applications. So this is a 3-tier something very important. Now here comes something more important things. The 3-tier architecture is a generic architecture. Again, it can be used by any company for any kind of application deployment, or even like we can use as it as a jump server as well. So in interviews, mostly ask question about jump server. What is jump server? So jump server is something a Bastion host. Bastion host. What is Bastion host now? Bastion host is something from where we can log in to the public. A user can log in who is having the access of this public subnet. Can user log in to the instance running in the public subnet? EC2 you can say. So if I'm going to run a EC2 instance in the public subnet, so it's going to be the public EC2 instance. And then from there I can log into the applications. So if you have seen, you might have seen in many companies, like there's always a Bastion host to connect to the backend application or even the database. The reason why Bastion host there, when we are connecting to the backend private EC2 instance, you can say there can be any application or EC2 instance. Even the applications are deployed in the EC2 instance. So you can have multiple EC2 instances here. So these are going to be the private EC2 instances. EC2. and then EC2. And this is going to be the database. So it can be having RDS. It can be again a EC2 instance, or inside it you can install run MySQL server, MySQL, or there can be you can say Postgres server as well. It depends on which kind of database you want to choose for your application requirement, or it can be a raw storage as well. EBS, you can say S3 bucket. That is a part of even AWS cloud account, but we can use it from inside the private subnet. So again, going back to the private subnet. So when a user Bastion host is something, a user will be connecting to the EC2 instance, which is going to be in the public subnet, and from this EC2 instance console, he is going to log in again to the private subnet. So this is called a jump server, because we are jumping to the private EC2 instance of the running in the private subnet from the EC2 instance running in the public subnet. There's a security group implemented. Only this public subnet EC2 will be allowed in the private subnet. So this is very secure stuff that nobody can directly log in. That's why it's going to be safe and isolated as well. So by this logic, we call this jump server, and in companies protect their backend also. And the same architecture can be used for application deployment as well. So if this time, if it is a jump server, now jump server, if we are going to log in into jump server, so how we are going to log in? We can, so front end can be connected, like from front end we can connect by SSH, HTTP. In the backend, like it's using curl, or you can web login or app. Anyway, we can connect to the front end. We can connect, and front end is going to be deployed here. So if it's a Bastion host this time, so we are going to use SSH. From SSH, we are going to use to log into the private subnet. If it is some another front end web page, then the same EC2 is now will be having a web page and or application deployed, which is just giving a front end. If it is something post or get request, then we are going to use the curl. Get request, then we are going to use the curl, like that. So, and there can be any method to connect to the front end. This is jump server, it's a SSH method. We are going to log in from SSH. It can be application login or anything. So this is some raw architecture of the three-tier layer. So the same now I am going to show you in how we design in draw.io. You can say in AWS what are the standard presentation of the architecture. So this is going to be look like let me show you. Okay, so it's going to look like this. So we are having here the AWS and public subnet and this private subnet, and here again a private subnet, which is having database application, and the front end. Public subnet is connected to the internet gateway, and there's a lot of concept behind these connections. And so in the interview, most of the time it is asked, the question asked is how the route table is having entries here. This is very important questions always ask in the interviews about this three-tier architecture, or even you can say it's a generic concept of VPC. If you are good to explain or good to understand or good to create this architecture in the VPC in the AWS account, then you will get everything about VPC, how it works, how the networking components are connected. So it's very important concept. So now come about routing table. So in AWS, there's a concept, each subnet we create inside a VPC. So a VPC is having subnet. So when we create VPC, we have to create subnet as well. So each routing table, each subnet is having its own routing table. Routing table is something which is having the entry of routes. Like destination, and source. Based on these routes only, it traverse the packet or something traverse to the destination or source route. So it's in front end, it's a public subnet. In front end, it's a public subnet. Public subnet will be having its own routing table. We will be saying it's public route table. The route table will be directing to the internet gateway in the public subnet route table, and to the local we say like to the VPC itself. And then again, private will be having its own route table. This will be pointing to the net. I will talk about net. Net is a network address translation. Since if the private subnets are only having any EC2 instance, if we deploy in the private subnet, this will be having only private IP. This will be having only private IP. Whatever, if we are connecting to the EC2 instance of the public subnet, or even the front end or any GUI of the public subnet, it's going to be having public IP. We can create even EIP, elastic IP to have the static IP, but it's going to be the public IP. So public subnet, this one more difference, like a private public subnet is having public IP for obvious reason, and private subnet is having private IP only. So there's IP range always, which is the standard, like when we are participating the IPs or assigning the IP. So there's a range of IP which comes in public IP range, and there's a private IP range. So private subnet is having private IP, and for that reason is private subnet is not able to connect to the internet. So what is net? Net is something, let me talk about net first of all, before I explain more about it. So what is net? If I talk about this is something net, what net does is network address. This is mostly asked questions in translation. You can say translator. So if it is internet gateway, and this is a layer of infrastructure, you can say firewall or security group, then any instance which is running in a private subnet, let's say this is an EC2 instance, and this is having private IP range only, because it's running in the private subnet. So it will be having kind of IP 10.0.9.0 slash something 24, let's say. So this kind of IP you can see for EC2 instance, that is you are going to launch as a private. It's not going to be the public IP. What are the private IP? Those IP which are used within the organization for a specific infrastructure setup. So we can take one IP CIDR range. So you can say to create subnet. So first of all, for example, if we create a VPC with the IP, we are provisioning the VPC with the IP 0.10.0.0.0/16. Then we have the option now. So this is something like we have chosen a private IP range. It's a complete range. From this, we will be creating subnets. So this is basically network ID. What is network IP? Network IP is something from which we can create more IPs or more subnets. And when we create the subnet concept, there comes one term, broadcast IP. So this is mostly asked question in terms of network. It's a generic question, because why this is generic? Because when we are actually working in industries, there are a lot of issues appears in connections. So to troubleshoot this connection, any individual should be knowing the difference between these subnets, how to create subnet, what are these IP, why this is what is this slash 16, what is the slash 24, what is network IP, what is broadcast IP. I'm not going to cover this because this is network component. I'm going to extend this the objective of this class. So when we take a VPC, we is having a network IP, we divide it to particular subnet. So we from this public private IP, this is private IP. So if any EC2 instance is having or any application is having private IP, it cannot connect to internet because there's a logic. When we connect to internet, we get a public IP to connect it. So how I'm going to connect to any remote servers. For example, there is a remote server. If I'm a user, so if I'm going to connect to the remote server, which is a public, or you can say not remote server, if I'm going to use facebook.com, then I will also get a public IP. So my laptop will also get a private IP as well as public IP. That because of this public IP only, I will be able to connect to the facebook.com or any remote pub server which is having the public IP. So the simple concept is, if I want to connect to the internet gateway or internet or public IP, I will need a public IP for sure. With private IP, I cannot connect to the public IP. So this is the concept, and the reason behind this is there's a range like private IP. If I'm having private IP, any user can have multiple private IP. So for now, my system is having some IP which is a private IP range, and if I open another laptop in the same network, I will be having another private IP of the laptop. This IP, internet is not aware about this IP that you are having, that this kind of IP. So this is falling in the IP range. Once if you are willing to connect to internet, then you have to tell your system that you need a public IP to connect it, because for now the internet is not knowing your private IP. Okay, so let's jump back here. So for that reason, network address comes in picture. So it helps to translate your private IP to public IP so that you can connect to the internet gateway. So this is simple. So now if your EC2 instance is this one, which is in the private subnet IP inside a specific VPC or subnet, then it will help you to translate this private IP, and for this private IP, it will associate it with the public IP. And because of this public IP, you will be able to connect to the internet somewhere, the internet gateway layer here. So this is network address translation in short, in very short. So the mechanism it does to bind this private IP to a specific public IP that it receives from dynamic protocol. So this is again a long theory that can be read on a separate topic. If you are interested to know more about it, let me know. I will create another video for that. So let's jump back. So here, let's come back here. So I was talking about the most important questions that are asked in the industries for knowing about jump server, how the 3-tier architectures are connected, how routing tables are connected. So here, my private subnet EC2 instance will somewhere be needing internet. So for that reason, the routing table of private subnet, that is private routing table, again another one for this one, will be connected to the NAT gateway. So NAT gateway will be in its entry, it will be having the NAT gateway entry and another entry to this subnet. So, but this is option of user. If they want to give in the destination the NAT gateway or not, because if you want to use internet in your system, then you need NAT gateway, otherwise not. Because to connect to the EC2 instance of private subnet from Bastion host, it is not requiring to having the public IP. There's no necessity to have the EC2. for EC2 instance to have the public IP to connect to the Bastion host, because Bastion host is having private IP as well as public IP, and from public IP it can easily connect. So Bastion host was requiring public IP because the user from external environment was willing to connect to the public subnet. That's why it was needing public IP. But to connect to the EC2 instance in private, Bastion host have private IP, which is already sufficient. Fine. So now routing table entry depends on the user. So if they're willing to connect the EC2 instance in the private to have the internet connection, then they will need a NAT. Okay. So here, as I talk, in most of the cases, like when we are downloading package for internet gateway or some binaries, then or maybe downloading a package from GitHub, then it most of the time requires the NAT gateway. That's why the application layer in private subnet requires NAT gateway in standard case. So this is, I think, sufficient. Let's jump back to the demonstration here. So this is going to be something which we are going to create in AWS platform. Now, there's something more. Let me. So here, where we'll be having that you can say we'll be having. This is pathetic. So this is having its own routing table, and this is again having an own routing table. So anyway, this is I already explained you in the previous run architecture. So okay, now this is a very standard three-tier architecture, but in my class I'm not going to create this three-tier architecture. You can get lots of code to create three-tier architecture. I'm in this class going to use Terraform to create the three-tier architecture, because the reason is with Terraform, because of since this is very complicated architecture, if I'm going to create manually, I have to go to the AWS and I have to create a user. I have to create a VPC. I have to create, if it is going to be multi-AG, then it is going to be more complex. So I have to create multiple VPC or multiple subnets, public subnet, and then have to create a routing table, and then have to map that routing table to the VPC. Lots of stuff out there. Even we have to create net gateway, internet gateway, lots of manual things. So to avoid this to create manually, I will prefer to use Terraform. So Terraform I will be using here. And another more concept is, this is since a standard 3-tier architecture, this can be created. You can create it from any source code there, even from the Terraform. Even the code, that Terraform code I'm going to use, from there also you can create 3-tier, this standard 3-tier architecture. But in here I'm going to cover a 3-tier architecture plus a Kubernetes cluster inside it. So what I'm going to do is, I just showed you here. I'm going to create this 3-tier architecture. Inside it I'm going to create a Kubernetes cluster. So how, what are we going to achieve in this class? I'm going to create a 3-tier architecture. You can say this one. It's in AWS. From my terminal. For that, I will be needing IAM user with access key, and the Terraform code I will be running in my local terminal, exporting the access and secret key of the this cloud account, so that Terraform can understand, okay, this is the cloud account I'm going to use here, keys. Okay. And with this Terraform, I'm going to provision a 3-tier architecture. Again, this is going to create a public subnet inside a VPC. You can say this is a VPC, and you can create another layer as well. And inside it, it is going to have a Bastion host here, as I just explained earlier, and two private subnet. So it's going to be the case. This is one single AG I'm explaining. This is single AG. I mean, it is one availability zone. You can have more than one availability zone cluster as well. So in that case, there will be a replica just like the same architecture. It will be created an another replica. So if I'm going to create multiple AG, then AG1 is this, then the same I have to create here, extend this and I create here. Okay, so Bastion host, and then Bastion host is, this is a private and this is a private. This I will be using for database. Okay, and this is I'm going to use for Kubernetes cluster. So what I'm going to create is, this is going to be 3-tier architecture, and inside it I'm going to create this 3 layers. The first layer is public subnet, which will be the Bastion host, and this private subnet is going to be the Kubernetes cluster. So the Kubernetes cluster, like we know, having create master and worker somewhere connected. So this is something we are going to create. So the first thing we will do is create 3-tier. Another thing I'm going to use is deploy Kubernetes cluster inside it, create, and then we'll be running a sample application. So to create the 3-tier architecture, I will be using again Terraform from my local. For creation of the Kubernetes cluster, I will be using Ansible playbook. And for the sample application, I will simply create a pod using the pod manifest. In the second part of this video, I will be creating a backend and front end. Actually, that is the purpose of this call, to create a 3-tier architecture with Kubernetes and deploying the front end and back end. Because in 90% of the industry deploy the same kind of architecture if they have already adapted the cloud or these automation orchestration technologies. So that's why it's going to be very, very important for everyone to understand this. Fine. So this is something I'm going to create with the Terraform. So let's jump back to the code. I have to make it very easy, I have already updated the code in my personal GitHub. Again, one more thing. There are lots of ways to create Kubernetes. So when we create Kubernetes, there are lots of ways to create it. We have a option to create Kubernetes via, okay, it's going to be the same dangling one. Okay. We can create the Kubernetes by Kubespray, which is actually the standard company follow to create it. We can create from EKS. We can create from KubeADM. There are many methods to create it. In industries, mostly the Kubespray is used because Kubespray has its own release automation, or you can say Ansible method to create a Kubernetes clusters. You don't need to create manually. there are two ways, like Kubespray. If we are going to set up architecture on our own, then by some commands firing after creation of VMs or EC2 instance, we can configure the cluster to be to make it a Kubernetes cluster. But there is a already Kubespray release in standard documentation. We can directly use those to create the Kubernetes cluster. Fine. So let's jump in this in this architecture creation. I will be going to use the Kubespray directly here. So let me jump back and show you. I have my code here in my repo already updated. I will be updating each sequence of steps that are required to create. So first of all, a user need anyone who's running this, he will need a few sets of requirements. I will be discussing about it. Let me log into my AWS account. So here I will be needing a user. I have already created Terraform user with AWS access keys and secret key. So once you create AWS IAM user with any name, it can be any name, it will automatically download the private key, the key for this user in your local, and you have to then create a access key for this users, because this is going to be used somewhere in the Terraform. So the first step is to create this user, and then once the user is created, go to the GitHub, download this code or clone this code in your